Hi, in this video I'm going to show you how you can use different finite element solvers within MCalibration. By default, MCalibration uses an internal solver to calculate the stresses and strains that you want to analyze, but you can actually use any of the other supported finite element solvers from within MCalibration. And once you set that up, you also need to worry about something called solver templates. And that's another focus that I will talk about here today. How does these solver templates work and how do you work with them? And let's get started. Here is an example that I've set up. It has a compression followed by unloading data. It's a load case on a chloroprene rubber. And I have already set up a polyumod 8-chain Arruda-Boyce hyperelastic material model. When you do this, typically this is all you do, and then you click run once, and you get a second curve in the graph here that shows the stress strain prediction based on this particular load case. But you may sometimes wonder, like, so how does this curve, where did that come from? How was that generated? And that was generated using an internal stress strain calculation that is built into the MCalibration software. But you can change that. So if I go to this load case and I double click on it and I go to the miscellaneous tab, you will see that there is a solver option here that allows you to specify what finite element solver you want to use for this calculation. The default solver is dependent on the material model. So for polyumod material models, the default solver is the built-in MCalibration solver. If you specify a certain, say, Abaqus or Ansys material model that is not yet supported by the MCalibration solver, it will switch over to a different solver. So the default solver is typically what you would use. But you can also directly specify what you like. You can say MCalibration here, and if I run it once, it will be exactly the same. It's a very quick calculation of the stress using the internal solver. Let's try something else. So if I go back to the miscellaneous tab, I'm going to pick Abaqus. You can either solve this using Abaqus Standard or Abaqus Explicit. So let's pick Abaqus Standard. There are some other settings here that we'll come back to, but just switching to Standard, I click Save. I can now run this if I want to, and it will actually launch Abaqus for us to calculate the stress response. Before we do that, let's take a look at some of the settings by clicking on Preferences, Abaqus Solver Settings. It specifies what version of Abaqus you want to use, and a little bit about what settings you want Abaqus to have. So we can delete Abaqus files once it's done, but let's deselect that so we can see them. And where do you want the Abaqus files to be stored? I use the same directory as MCalibration in this example. So click OK, and then I'm just going to click Run Once. What MCalibration is doing now is generating a file, an Abaqus input file, that is based on this experimental load case. And it asks Abaqus to solve that for you, to calculate the stresses, and then MCalibration will extract that information in the end. So we can look at the files, what's going on. This is the directory we're in. You see there is an STA file here. There's some other files that Abaqus is running right now. And these files were generated by MCalibration. It's fully automatic, and we set MCalibration to not delete them when it's done. And I think it may have finished now. So we go back here, see, here's now a prediction. The blue line looks the same as before. We have switched to using Abaqus as the solver in this case. So the idea here with solver settings is that you can modify what Abaqus does when it runs this by going to the edit input file template, for example. So if I click on this, you will see the actual Abaqus commands that MCalibration are generating for this load case. So it's a certain number of nodes. You can see them here. You can see that this is a block with size 1. It has a C3D8 element type. It reads in certain settings here, and it has an amplitude definition. This is fully automatically generated by MCalibration to perform this calculation. So if I click Save, it will just keep that default template. But you have the ability here now to edit this template if you like. You can change it if you have some certain desired settings that you want Abaqus to follow. So one thing I can do here that's very easy to demonstrate, I can just switch from regular elements to hybrid elements. So I'm going to just put an H on this. If I do that and I click save, I can run this again. And if I do that, then Abaqus will run the simulation using a hybrid element type. So you can switch up whatever settings you like Abaqus to do by editing that solver template. To understand how this is done behind the scenes, I'm going to go and actually open the MCalibration file that I just generated. So what do you mean open it? Well, I'm going to open it with a text editor. So an MCal file is an XML file that contains the commands that you have specified within MCalibration. So I want to demonstrate that here. So in this case, there is a load case. That's the one we're working with. And it has the actual experimental data in here. But now, since we modified the solver template in the dialog box that we just showed, MCalibration actually solves the modified version of the solver template that we created. And that's available here. So if I close this text editor and go back to MCalibration, it remembers that we modified that solver template. If you want to go back to the original solver template that MCalibration uses, you can do that as well. And that happens by as follows. You go to the Miscellaneous tab, you click on Edit Input File, and then you get this warning. It says the saved template is different than the default. You want to use the saved one. If you say yes, you get back to the version that you already have modified. That's the one with the hybrid element here. But if you want to switch back to the default template, you say no, then MCalibration will switch back to the automatically generated template. And if I save this, now my modified template has been removed and it's using the default one. And the default template is not saved in the MCal file that we just opened. Of course, it's the default. It's automatically generated every time, so you don't need to actually save it. So that's how you can modify a template in MCalibration. You can also do this for other FE solvers. If I switch over to Ansys, in Ansys, you can edit the solver template as well. And here's the file that MCalibration generates for Ansys. So this is a generic file that has a number of nodes. You can see them here. The element type is 185, and there's an amplitude definition and so forth here. So you can go ahead and modify this template in the same way as just demonstrated for Abaqus. And the same applies to the other finite element solvers that are available within MCalibration. So this is a useful feature. Sometimes you will need this in order to tweak the automatically generated solver file that is used by MCalibration. And hope this was useful. Let us know if you have any questions.